On the surface, Mississippi State University presents the image of a traditional state-funded academic institution. For the Department of Defense, a public university offers a specific logistical advantage. It provides a civilian environment where researchers develop biological and cognitive models, away from the stringent ethical oversight and transparency required on a military base. The Research and Technology Corporation acts as a fiscal firewall, separating classified defense contracts from the public university ledger. This allows the RTC to acquire off-campus properties, like the Downtown Innovation Hub. Moving off the academic grid bypasses standard Freedom of Information Act requests. The anchor tenant of this off-campus facility is Babel Street, a global intelligence contractor. In these secure workspaces, civilian researchers and student interns co-locate with a firm tracking commercial cell phone data to map human movement for military intelligence. Through this architecture of legal proxies and off-campus nodes, the university creates a persistent blind spot, allowing defense operations to scale without entering the public record. This intelligence supply chain depends on the continuous extraction of biological data, much of which is centralized at the Athlete Engineering Institute. Inside clinical-grade immersive environments, the institute places subjects into virtual reality simulators to monitor their gait, physiological stress, and biomechanics in real time. This research focuses on a specific demographic, tactical athletes, including military personnel and emergency responders. The ultimate consumer of this biological telemetry is the Air Force Research Laboratory's 711th Human Performance Wing, headquartered at Wright-Patterson Air Force Base. The 711th is tasked with studying cognitive dominance. Their active research includes mapping how the human nervous system reacts to electromagnetic interference and the biological effects of directed energy. Training the targeting algorithms for these systems requires high-fidelity human telemetry. The Athlete Engineering Institute fulfills this demand, harvesting the data necessary to construct digital twins used for military stress testing. The institute operates as an ethically sanitized biometric harvesting engine, designed to provide the baseline data required by autonomous cognitive weapon systems. Processing millions of biometric data points requires massive computational infrastructure, a requirement met by the Applied Research Collaboratory and the Neural Engineering Research Division. These facilities utilize supercomputing arrays integrated with machine learning models. Their work involved decoding high-speed electroencephalography signals to map how the human brain transforms sensory input into abstract concepts. The military applies this computational power to a specific biophysical problem, calculating the exact thermoelastic acoustic pressure generated inside a human skull when brain tissue is struck by a microwave pulse. Rapid thermoelastic expansion is the established biophysical cause of the directional acoustic anomalies reported by government personnel at the United States Embassy in Havana. The mathematical models used to map how concussive shock waves ripple through brain tissue are functionally identical to the equations the Air Force uses to calculate a microwave neurostrike. The supercomputers funded for public health and sports safety are actively running the in silico physics models required to execute targeted cognitive electronic warfare. With the targeting algorithms trained and the physics modeled, the final hurdle is physical delivery. This requirement is met by the Advanced Composites Institute. The DARPA Brainstorms program is engineering a non-surgical brain-computer interface. This system relies on injecting magno-electric nanotransducers into the bloodstream, where they travel directly across the blood-brain barrier. To survive the human circulatory system, these nanoparticles require a specialized coating. They must be enveloped in synthetic polymer resins that hide the hardware from the host's immune system, while allowing the conversion of magnetic fields into electrical pulses. Manufacturing these fluoropolymer resins requires industrial-scale chemical synthesis. To execute this, the defense contractor Battelle awarded a grant directly to the Advanced Composites Institute to formulate these specific coatings. This outsourcing relies on strict compartmentalization. The academic chemists formulating the polymers hold security clearances strictly for material science, leaving them insulated from the eventual neurological applications of their work. By dividing the labor across disparate academic nodes, defense contractors secure the hardware for neuroweapon systems while maintaining plausible deniability among the researchers. This architecture forms a closed, continuous intelligence loop. The Research and Technology Corporation shields the contracts. The Athlete Engineering Institute harvests the biological targets. The Collaboratory models the strike physics, and the Composites Institute engineers the delivery hardware. Because each department operates in isolation, viewing only their fragment of the project, a comprehensive cognitive kill chain has been constructed in plain sight. The entire system is dependent upon corporate holding shells and the illusion of academic independence. Its greatest vulnerability is public exposure. Disrupting this network requires lawmakers to subpoena the financial ledgers of the Research and Technology Corporation and force an unredacted audit of the Applied Research Collaboratory. The human mind is not a battlefield. The corporate mechanisms quietly funding its weaponization must be dismantled. This investigation is led by the Neuropsychological Warfare Alliance, using declassified military documents and whistleblower testimony to expose the civilian kill chain.